later, but I'll talk on this one.
Okay, what I want you to do is grab a marker and then write on your desk. Yep. Okay, we've got to make sure before we can do today's lesson that you can do all the stuff we've learned this unit. So what I want you to do is answer these 5-1 review problems. If you can't do these, you're in trouble. They're Pythagorean theorems. Okay, ready, set, go. Do both of them. Go, go, go.
Now you can do sine, cosine, tangent. So 3 goes here because you did the Pythagorean theorems. Now answer sine, cosine, tangent. So what's this saying? Everybody shout out. Oh heck, another hour of agony. Here we go. So, oh, I forgot to put a theta in so you wouldn't know exactly what sine is without a theta. So I'll put the theta down here. Okay, so 3 over 5. 4 over 5. Yep, 3 over 4. Very good. Were you all able to understand how to do that?
Yep.
Okay, next one. Now it is going to be, notice, find the measure of the angle indicated. So this is the one where we go all the way. You find theta. So remember, how we do these ones is we set up a true statement and then solve for theta. You got to go all the way. Ready, go. Set up a true trig ratio. It's not always sine. You got to set up a true one or you'll be wrong. Okay, I want to make a point here. This is actually a good point that Johnny made. We could go through and find the hypotenuse because we're given the other two sides. However, it's unnecessary. No, it's 5 divided by 4. I hate to tell you. So we have here a triangle. Which trig ratio did you use? Tangent, because we have the opposite and the adjacent side in that order. So the true statement is tangent of theta equals 5 over 4. And then you'd say to yourself, what am I trying to find here? I'm trying to find theta. So I need to undo tangent. So tangent inverse of both sides of the equation. That one does that. So theta equals tangent inverse of 5/4. Did anyone else get 51.3 degrees? Okay, awesome. You're going to need to remember how to do that for today's lesson. Okay, questions on that? Okay, ready, set, go. Solve for x. So once, yes? Oh, the inverse, you mean? Good question. So guys, the question was this. Please listen. Hey, don't talk. So the question was this. Do we always use the opposite, which meaning the inverse? Well, that, yes, but only if we're trying to undo and find the angle. So we would never do the inverse if I just gave you tangent of 53, because then you're going to have 53 degrees floating in the air. Does that make sense? When we're trying to solve for what's trapped inside, yes. Okay, so now solve for x. So now notice, on this one, you can't use Pythagorean theorem because we weren't given two sides. So you'd say to yourself, I have to set up a true trig ratio and then use algebra to solve for x. See if you can do this, because if you cannot do this, you can't do today's lesson. So set up a true trig ratio. So remember, what did we use as theta? The angle that's given. So wouldn't this be theta? And then what's this? Opposite and hypotenuse. So which one should we use? Sine. Okay, go. See if you can do it. Hey, I think that back group's got it back there. So what's my true statement here? Opposite and hypotenuse. Which trig ratio uses opposite and hypotenuse? You say sine of theta equals opposite over hypotenuse. Plug in everything you know. Do you know theta? Okay, then put it in. What's our opposite side? What's our hypotenuse? 10.2. Then you say to yourself, what am I trying to solve for? X. So use algebra to get x alone. We always multiply by what's on bottom, because what undoes division? Multiplication. So now to solve for x, what am I going to do? times 10.2. If I do that to one side, I have to do it to the other side. Now look, they divide out. Isn't x alone? Yeah. I've reached my goal. So now you just type it in. You guys, you don't type in the inverse side. Does everybody understand the difference between this problem and the last problem? The last problem, our true statement was sine of theta. You didn't know theta, but you knew both of these sides. So do you see how now solving for theta, to get theta when I take the sine inverse? Do you see the difference in the problem? Yes or no? You see how this one has the unknown trapped inside? So that's why we have to do sine inverse. You see how the unknown is not trapped inside? Yes, 6.4 was my answer. Hey, redeem yourself for those of you that did not get it right, which was pretty much everybody except for that group. Do this one. Do this one. So my true statement was tangent of theta equals opposite over adjacent. Put in everything you know. Tangent of 22 equals my opposite is 7, my bottom's x. We always multiply by what's on bottom. Now I'm going to ask you, I'm going to make a point here. Would you undo tangent in this one? No, because then you have floating 22 degrees, right? Okay, good. Multiply both sides by x. So now you have x tangent of 22 equals 7, because our x is divided out. You'd say, my goal is to get x alone. How do you undo multiplication? Division. So we're going to divide by tangent of 22. Divide by tangent of 22. And now you just type it into your calculator because x is alone. 7 divided by tangent of 22. What'd you get? Okay. Let's do, because so many people don't understand, I'm going to change this problem, okay? And you're going to do another one. If I say solve for x, solve for x, ready, set, go. So in this one, isn't x my angle? So you're going to come up with a true statement and then put things where they belong. Set up a true statement, put in everything you know, and then solve for x using algebra. My true statement in this one, every time you do the same thing, you set up a true statement. So tangent of theta is opposite over adjacent. Put in everything you know. Do we know theta? Well, it's x, isn't it? Yeah. Our opposite side 7, the bottom's 8. Now guys, you can't just do the same thing every time. You have to actually think. Should I be multiplying by 8? No, because isn't my goal to get x alone? So you'd say, okay, x is trapped inside tangent. How do we undo tangent? Tangent inverse? We just did like 3 problems like this, everybody. Tangent inverse. And then you're undo. Do you see how x is alone now? I'm just confused on what we're confused on, so I can answer it. Anybody know what they're confused on? But do you see how every time we do the same thing? We set up a true statement and then we solve for x. So it just depends. You might be multiplying by the bottom or you might not. If you're undoing and trying to get the angle alone, you won't. Any other time, yes. Does everybody get it? Should we just move on? Because we're going to have plenty of practice actually from the homework. Let's do some examples off the homework. Here we go. Go to problem number, hey, these are 2 words you have to learn real quick. They're pretty easy, so everybody look with me. So if I say to you, find the angle of elevation, this is what the angle of elevation is. So if there's a person standing and they're looking up at a flag, look, there's their eyeballs. Here's an example. Look, I'm standing right here. And I look up at that flag. The angle of elevation is literally made from the ground, because my eyes started at the ground looking up. This would be my angle of elevation, from the ground up to where you're looking. So if I said find the angle of elevation from me to the map sign, that would be this angle down here. Do you see how this is just a right triangle? Okay, now here's the difference of angle of elevation and angle of depression. Angle of depression is not... A lot of people get this mixed up. So angle of depression, if there's a bat going to attack a snake or whatever, looking down at a snake. Okay, could be, right? I'm not quite the artist that I could be. So Angle of depression, a lot of people get wrong. They think it's this angle right here, but it's not. You see how we have a right triangle here? Angle of depression is from, you're starting up high, your eyesight starts up here, and then you look down. You see how that creates the angle up here? Do you see how that's not in my right triangle? That's a problem. So what I want you to understand is angle of depression is not in the triangle. It is not this angle. That is not the angle of depression. It's the one that's outside of the triangle. So now this angle and this angle are called alternate interior angles. Do you remember learning that? So they're the same. So this is also the angle of elevation, isn't it? From the snake looking up, the angle of elevation is down here. So guess what? Angle of elevation and angle of depression are the same. So if I said to you the angle of depression from my eyes looking down to the garbage can, I would create this angle up here. So then we'd have to flip it and put it down here. Does that make sense, everybody? Okay, now we can start. So go to number 1. All my examples are coming off your worksheet. Everybody listen. This lesson is super easy. You have to think about it in the real world. How do I draw a real picture of this? Just think about it. So it says, a monument stands on level ground. So I'm going to draw that. Okay. Here's the ground, a monument. So I'm just going to draw like a square. Does everybody see why I would draw it like that? It's literally drawn in like the real world. It says the angle of elevation to the top. Sorry, I have a bad cough. The angle of elevation to the top of the monument taken at a point of 400 feet away is 32 degrees. So now isn't that from the angle of elevation to the top, here's the top. Good, so wouldn't my angle of elevation be down here? And it told us that 400 feet away, the angle of elevation is 32. So you'd put in your 32 degrees down there, and that's 405. Now it says, find the height of the monument. Am I going to put that here? No. Think about it in real life. That'd be this. So now I have a right triangle, and all I have to do is solve for x, just like we just did a second ago. So what's my true statement in this problem? Isn't this theta? We're given opposite and adjacent. Which trig ratio? Nope. Oh, yeah. So say, what's my true statement? Tangent of theta equals opposite over adjacent. I want to see you writing that out every time. Now you'd say to yourself, I'm going to put in everything I know. Tangent, do we know theta? Okay, then put it in. What's our opposite side? X. What's our adjacent side? 405. Now you'd say to yourself, my goal is to solve for x. Should I undo tangent in this one? No, because then we have a floating 32 degrees, which is not good news. So what we're going to do is get rid of the fractions. How do we undo 405? Good, multiply both sides by 405. Then you'd say, have I reached my goal? Is x alone now? Okay, then all you have to do is type it into your calculator. 405 tangent of 32, go. 253.1, perfect. 253.1 feet. Because it was 405 feet away. You see how easy that was? Yeah. They're all that easy. It's just trying to correct picture. So let's do one more. Okay, let's think about this one. The hardest part is drawing a correct picture, but if you just think about it in the real world, it's not hard. So look at this one. A boy is flying a kite. That's flying a kite lets out 150 feet of string. So let's think about it. Here's our boy. He's flying a kite. Right? Now it says he lets out 150 feet of string. Where should the 150 go? He lets out that, right? So isn't this 150 here? Okay, because he's holding on to it right there. Then it says that make an angle of elevation of 64 degrees with the ground. So isn't this the 64? Everybody? Because the angle of elevation from the ground looking up to the kite. And then it says, how high is the kite? So it asks us how high, so shouldn't x be here? Yeah. Okay, now let's set up a true statement here. So we're given theta, opposite and hypotenuse. Isn't this my right triangle, guys? So sine of theta equals opposite over hypotenuse. Oh, heck. Plug in everything you know. Sine of 64 equals my opposite side, which in this one is. And my hypotenuse is 150. Now solve for x. I shouldn't undo sine because then I have a floating 64 degrees, which is wow. Yep, multiply by what's on bottom. So we multiply by 150, 150, and it divides out, and x is alone. So that's how high it is, 134.81 feet up. Yep. Okay, we're almost there. That's all you gotta know pretty much. Number 3. It says a person in a balloon, which is 2,000 feet above the airport, finds the angle of depression to a ship out to sea is 21 degrees. So let's draw a correct picture. A person in a balloon, so they're in like a hot air balloon. There they are. That's a hot air balloon, I guess. Yeah, it does. So a person in a balloon, which is 2,000 feet above the airport. So isn't the airport down here? Okay, let's write airport. Okay, and then this is 2,000. It says they look out to sea. So they look out to sea. So isn't that out here somewhere? And they see a ship. Here's my ship. And it says they look out to sea is 21 degrees. Now, careful, because isn't this starting eyesight up here? Would it be right here, though? Good catch. So this one's, his eyesight started up here, and then he looked down. So unfortunately, the 21 degrees is out here. Now, notice that's not in my triangle. Now, it says find the horizontal distance. Horizontal means the ground up. This is the horizontal distance. So this is my x. Does everybody understand? Now from here, since this is my angle of depression, where should I put my 21 degrees in my triangle? Because see how it's not in the triangle right now? We can't use it till it's put in our triangle. Where should that go? Good, down here, yes. That you were going to say? Perfect. Does everybody see why?
Yeah.
Alternate and true. So now we can set up a true statement. Here's theta. Opposite and adjacent. Tangent. Tangent of theta equals opposite over adjacent. So solve for x. Once again, should I undo? Oh, no crap. I didn't put in what was theta. Rewriting it. Tangent of 21 equals 2,000 over x. Now solve for x. I shouldn't undo tangent in this one because then I have a floating 21. What should I do? Good, multiply both sides by x. So that divides out. So we have x tangent of 21 equals 2,000. And then you say, my goal is to solve for x. What should I do next? Divide by tangent of 21. Now look, they divide out, and isn't x alone? Now type it in, 2,000 divided by tangent of 21. Okay, cool. Pretty simple. That's how much horizontal distance is between it. Okay, last example, and then the rest of the time will be yours to finish. Number 5. It says, find the angle of elevation of the sun when a 24-foot tree casts a shadow of 36 feet. You've got to draw a correct picture. So we have a tree casting a shadow, correct? It says that this tree is 24 feet high, casts a shadow of 36 feet. It says, find the angle of elevation, so isn't that from the ground up to the sun? So there's my right triangle. So aren't we trying to find this angle? Everybody? Angle of elevation is from the ground up. I didn't draw that very good, did I? I drew the sun in the wrong spot. Confused myself. Sorry, it says the angle of elevation, sorry, it's from the shadow up to the sun. There we go. So this will be our angle, right? Yeah, because this is what's creating the 90-degree angle to the ground is the tree. So now opposite and adjacent is tangent. Okay, so I have a true statement. Tangent of theta equals opposite over adjacent. Plug in everything we know. Do we know theta?
Yeah.
No.
Wouldn't it be 11?
No. Where'd you get 11?
Anywhere 11.
It doesn't say that anywhere.
That's right.
We're doing number 5.
I didn't know that. Oh, I thought we were. Yeah.
It says 5 right then. Okay, so everybody, do you see how we don't know theta? Isn't that what we're trying to find? So we have tangent of theta equals opposite over adjacent. Now in this one, should I multiply by 36? Should I? No, isn't our goal to get theta alone? How do I get theta alone in this one? Tangent inverse, tangent inverse. That one does that. So theta equals tangent inverse of 24 over 36. What is it? So make sure you draw a correct picture, set up a true correct statement. Okay, so you only have a few left to do. Do them correct. Ready, set, go.